This is 4a. At time equals 0, a boiled potato is taken from a pot on a stove and left to cool in a kitchen. The internal temperature of the potato is 91 degrees. Okay, so that's the key thing. We don't really care that it's a potato. All we care is that the temperature at time equals 0, so we'll say capital T of small t, that temperature is going to be 91. And the internal temperature of the potato is greater than 27 degrees for all time. I'm not sure why they would give me that. The internal temperature of the potato, t minutes, at time t, can be modeled by the function h. So I don't really need to use this t thing. They're giving me h. So now I know that h of 0 is 91. This formula H satisfies the differential equation here. So what that means is they're giving me amount and rate. The formula for calculating the amount, in this case the amount is a temperature. And the degrees are in Celsius. And it's the formula H that can be calculated at any time. That's my amount. The rate at which the temperature is changing, that's the differential equation, dH dt. So the rate at which the temperature is changing, that's dH dt. Negative 1/4 H subtract 27. I guess that would be important. They said that the H never see, the internal temperature of the potato is always above 27. So H is always above 27, which means this is always above 0, so always positive, which means multiplying by negative. We know that dH dt is always negative. dH dt is always negative, which makes sense. This is the rate at which the temperature of the potato is changing, and because the potato is simply cooling, the temperature is always going to be decreasing, so the rate of change of the temperature will always be negative. And then we also know this already, the temperature at time 0 is 91. Part A says, write an equation. So be careful here. They don't want just the slope, they want the equation of the line tangent to the graph of h. Equation of a line tangent to the graph of h at time equals 0, and then there's a period. So we want to do that first to get those points. So I think of my picture again. I've got h, that's my temperature. And in this case, it's different than my usual picture. The temperature is going down somehow. They want me to write an equation of a line tangent at time equals 0. So I go here. They want an equation of this line tangent at time equals 0. So something like that. Drawn kind of badly, but they want the equation of that line. So I know the equation of that line will be something like this. Y equals slope of that line. I'm dealing with time now, not x. So something like this. So got to find the slope. The time 1 here is 0, and the first y value is 91. That's what they told me right here is on the graph of h. At time 0, the value is 91. So now you just need to go find the slope of that green line. But remember that as we read the problem, we figured out that this formula dH dt is how we would find the rate of change or slope of this. So we've just got to go find the slope of h when time is equal to 0, which means we've got to find the value of dH dt when time is equal to 0. So that's what we do here. I'm finding dH dt when time is equal to 0. So I take my dH dt formula and I plug in right here. It's not time I'm plugging in, it's actually h. But it has to be the value of h when time is 0. Otherwise it wouldn't make sense. So if I get the red box, that's 1 point. You needn't go further. You can. If you do successfully, you'll still get that 1 point. But the red box is 1 point alone. Now I take that slope and I put it into my formula right here. So I get this green box here. Let's see. Oh, interesting. So this first green box, I was showing you that you don't have to really reduce all this. You can just leave it like that if you want. I'm not sure why I have 2 negatives. This is a mistake. We've got to fix that. So it's just this formula plus the 91. There's my t subtract 0. Or the easier way to see it is right here. But 1 point for writing the equation. 1 point for writing the equation. You really shouldn't keep simplifying, but if you did correctly, you'd still get that 1 point. So 2 points so far. Use this equation, so this one right here, to approximate the internal temperature of the potato at time equal 3. So we're basically assuming that we can move over here, and we'll just pretend that right there is time equal 3. So we're trying to find the internal temperature of the potato, which would be this y coordinate here. But we're supposed to approximate this y value by finding this y value. So the slogan is, I can take this equation and I can plug in any time and I can find any y coordinate on this line. Or I could do it the other way around if necessary. I could plug in a y coordinate and find the time that corresponds. So I'm going to plug in time equal 3. That's going to give me this y value. So I could plug it into any of these. Wouldn't matter. Any of these would be fine. This one's probably the easiest to plug into. So right there, I plugged it in. Don't have to go further. Just say the internal temperature of the potato at time 3 is approximately this y value. And then you can stop and you get 1 point for that. If you went all the way, you'd find out that our approximation is the potato has an internal temperature of 43. You needn't keep going. You don't get more points for going further. You just risk losing points.